Hello, good afternoon everyone. Uh, Welcome to this talk on MIPS processors, data centers and 5G communications, and how the MIPS RISC-V CPUs are used in heterogeneous computing. My name is Srinivas, called Keshri. I lead the software and platforms team for MIPS in India, based out of India. And before I even go and start the presentation, I hope you had a chance to go to our booth, and we are very proud to say that yesterday we won an award for the best product under the SoC category. So that's a testament to the cool technology that we are developing, and today I'm going to talk about how this technology can be applied in some of these applications. These are very compute intensive applications. Okay, so you all know MIPS. MIPS is a very popular name in computing world. Back from 1980s when we pioneered the RISC development, and over a period of time MIPS has undergone a lot of changes, but eventually we came back with certain key capabilities over a period of time. We had multi-threading capability, which is very unique, hardware multi-threading. We have multi-core capabilities, which enable you to scale the compute systems in today's world. We have multi-cluster capabilities to address really large compute farm requirements. And coupled with that, with the RISC-V revolution that is happening, we have got the capability of a whole lot of RISC-V ecosystem that comes together. So you've got the best of the both worlds with the MIPS RISC-V as well as MIPS and the RISC-V coming together. And we are here to innovate, right? I mean, the innovation is in giving higher performance, lower power, lower area, and how do you make the whole development easy for our customers. So let me start by picking a couple of applications, and the theme of the talk is about 5G and data centers. So if you take 5G, you have got the core network, and 5G is designed to make sure you have got these different configurations of network easily accessible and used by the customers, right? You have got the 5G CPE at the lowest end. You can also customize 5G for industrial IoT type of applications, low latency. You can deploy your own 5G network within a factory automation floor, and you can have your traditional 5G macro cell like what we all use, or you can have an open radio access network. So it's highly flexible. And what that flexibility brings is a challenge, which is how do you build a system that can scale from a small CPE at your home where you connect your 5G radio to your wireless LAN, and then you have all the data routed through the WLAN, and you still use your phone as if it's a 5G network, or you go to a big macro cell where you have a large deployment, or you have an open RF solutions where customers are going and telling, okay, I'm going to make this small tweak, for that specific operator. So you have this such a wide flexibility, and that is what is defining everything defined by the software. And when you have a lot of software defined solutions, you are not limited by the ASIC solutions that you are using in 4G and significantly in 3G. So how do those things work? If I'm taking a CPE, for example, customer premises equipment, probably a single processor is good enough. A very high-end single processor suffices. But when you go for a small cell configuration, maybe in an industrial automation floor or a factory automation floor and things like that, you may need a couple of those processors coming together, and you need that much of compute power at the edge. And then you go to a macro cell, you have thousands of people like this show, and you need that capability to have multiple channels working together. So what happens is, in all these cases, you need a general purpose processor for these different target applications to do the baseband processing. That's a given. And these processing is over a number of channels, and I'll talk about how our products will help in such applications. And when you have got multiple processors coming together, you form a cluster, you form multiple clusters, you need a strong L2 to share within a cluster, and maybe a system L2 or an L3 type of a setup to share across multiple clusters. Coherency plays an important role because what a cluster or a core is doing here should be known to the core here, and you need a wide range of programmability. And this is not just about vector processing, right? This is about multiple streams of data being processed by different elements at different times, but somewhat similar. When we go to the data centers, traditionally data centers have got the Intel CPUs doing both your compute as well as non-compute work. And the non-compute work is storage and network operations. And it is just not efficient. You have got 3 gigahertz of performance, and then you want a time slice of each of the performance. It's okay, but as data centers are exploding further, you will need a low latency, you need a dedicated hardware to do all this processing. And this dedicated hardware is very much possible by replicating the CPU, but then you're going to pay a bomb to get that. So what we do is, you get into a new category of products called the DPUs. And what the DPUs will do is, they're dedicated to interface with an HDD or an SSD or even the network. And you have multiple streams. Every user has got a stream of data, and then you keep dedicating that particular processing of that stream with a thread, with a CPU, which is low cost, low latency, and highly efficient. So you have got these two different applications as the theme, but a very similar theme, which is you have got a number of threads and you want to support this multi-threading concept, and that's where I think MIPS will come to the rescue. It enables you to innovate heavily with such architectures. So what we have is a Evo core P8700. It's a RISC-V high performance. It's the highest performance RISC core that is available today. Itai talked about it yesterday, about its application in automotive systems. So what we are talking here is, this is a core with capability to go up to 2 gigahertz of performance. It's a 16-stage pipeline, and you can have 8 instruction fetch, and you have multiple execution units to run. We support out-of-order execution, which means you are filling the pipeline very, very efficiently so that you get the best out of it. And as if it is not sufficient, we are going and adding a lot of bit manipulation instructions, extensions to RISC-V, cache extensions, just to make the processor that much more powerful for these applications, because you need a lot of bit related processing when you have bit streams in communications. We also have a coherency manager, and this coherency manager will enable you to bring coherency between the caches when you have a cluster configuration. And what is the cluster configuration? We can put 8 cores on a single bus and form a cluster, and whatever external memory you are accessing, that gets replicated on the cache, and hence you maintain a cache coherency. We also enable I/O coherency, and that's again another nice feature to enable up to 8 ports. It's a coherent bus on the I/O space. So what is MIPS giving us a competitive advantage, right? We have the multi-threading support. As I said, it's very important to have that multi-threading support for these applications. It's perfect. And with multi-cluster, you can have up to 1024 threads in a cluster, of 64 clusters, and each cluster having 8 cores, and then each core having 2 threads. This multi-threading will give you a low latency context switching, so which is very good if you have to switch between the context and then do some additional processing. And if you are doing an out-of-order execution, as I said, you are not wasting anything in the pipe. You are filling up the pipe as much as possible. And because of a 16-stage pipeline, you get a very high frequency as well, which is great. We have got features like branch prediction, and some of the spice inside that improves the performance of the pipeline. And more importantly, we build one platform with multiple configurations. We give to our customers whatever specific configuration that they need. We are not just giving a core, but we build the platform and the configuration that helps our customers. So it's a very seamless integration for you, for your customers. In terms of threading, I spoke enough about multi-threading, but one thing I want to tell you, this is hardware multi-threading. So you've got multiple threads that are managed in the hardware, and what it means is you will feel that it is just like another core. You are not thinking about these threads as a software managed threads. It's just another core. But the efficiency that you will get is around 40 to 50%, obviously, because there are some resources that you share, the memory bottlenecks will be there. But the cost of it is only 10%. If you reproduce the hardware, if you reproduce the core, you are charging 100%. But here it's only a 10%. So you've got a good bang for the buck. And you could even do a lot of sort of a virtualization by running two operating systems and completely isolating them. That's a nice little feature. And what this means is, from a benchmarking perspective, compared to any other competitive RISC-V product, we are close to 75% better than the other products. And even the best automotive CPU cores are beaten by around 35%. So this is the truly high-end performance that you will see from us. And multi-threading obviously gives a far more advantage. As you can see here, anywhere between 65 to 40% advantage, depending on the number of cores you use and how you set up the system. As I said, we scale up to 64 clusters, 8 cores. For you to build the SoC, it's a very, very coherent NOC you have. You don't need to do anything around customization. When you reduce the number of clusters or the number of cores, it's highly flexible. We offer tools. We provide the development environment. We provide Linux. We provide the debug environment. And these tools are available from us already. We have a lot of benchmarks that we have implemented. Apart from P8700, I also want to talk to you about i8500. This is also a product which we have announced. It is also very similar in terms of number of threads, but it is not an out of order execution. It's a triple issue pipeline, so it's slightly lower in performance compared to P8700, but it does serve a lot of application. It's a RISC-V core. You have compatibility with your software. So depending on your application, you could scale things up and down. In fact, we also have some customers who said, hey, can I use 8700 in one cluster and 8500 in another cluster as a big little configuration? Very much possible. So it is a flexible architecture that enables you to plug in and use this whole system in multiple ways. So in summary, I would say that MIPS is having a lot of strengths from its past on the CPU technology. We have leveraged all of that and brought that into RISC-V, given the way RISC-V ecosystem is developing and it is growing. Some of the newer applications like the 5G data center are really high performance applications. You will need CPUs at low power, you will need CPUs with high performance, and you need scalability. You cannot be fixed on a specific architecture, but you need flexibility and scalability, and we provide that. Custom instructions are a key in RISC-V, and we understand the domain and we are adding up those custom instructions, and we can also work with the customers to support any additional custom instructions as possible. So this Evo Core is a family of products. It's designed for you for those high performance applications, and we welcome any questions, and we are glad that we have won the award yesterday. Thank you very much.